Hi everyone, I'm Pravalika. My new ID is TN567. In this video, I'm going to explain about linked list implementation and operations. Firstly, I'm going to write my code in this online compiler. Firstly, I'm including my input, standard input output library. I'm also including the standard namespace. Next, I'm creating a structure to define a node in the linked list. So in this node, we have a data part. So I'm declaring data part as a variable named data. I'm also going to declare the address part, which is a pointer, which is stored in next variable name next. Next, I'm going to create a constructor to initialize the node. So constructor, we have the same name as the node name, which we defined before. It takes the value as its input. It also takes the data part as well as the address in the next part of the node. Initially, it's gonna be null. If there is only one element present in the linked list. I'm closing my structure now. Next, I'm defining a class to perform linked list operations. I'm giving my class name as linked list. I'm also declaring a pointer to indicate the head node of the list. It is stored in the pointer variable name head. I'm also declaring a pointer to store the last node of the list. Public. I am creating a constructor for the above linked list class. It takes head null pointer as well as tail null pointer. Next, I'm also constructing a function to add an element at the end of the list. So I'm giving the name of the function as append. Takes a value here. Next, we are going to create a new node with the given value. I'm using new keyword, which gets the value. Next, I'm going to check if the list is empty. Then the new node becomes the head. Using this condition to check if the list is empty or not. If the list is empty, then head will be equal to tail equal to new node. If the list is not empty, we append the new node at the end and update the list. Appending new node to at the end, which means using the tail, since it is the end of the list. Next, our tail will be equal to our new node. Next, I'm going to print the last element after insertion into the list. So last element after inserting, which will be our value. Last element will be at the data part of our tail. So next I'm using a function to search for an element. This function returns Boolean value, true or false. It's the value which we have declared before. And we are going to traverse to the list and check if each node's data. So if our current node equal to our head, since we are going to traverse from the list, so our current node should be our head. It should not be equal to our next. Next, I'm going to return true if the element is present in the list. I'm using this condition. If the data present in the current node equal to our value, then it will return true. Else it will return false. So this is how I searched for an particular element. If the particular element is present in the list, next I'm going to construct a destructor to delete the memory. So destructor will have the same name as my class. We are going to delete all the memory by starting from the head. Next, I'm going to create a temporary pointer variable. Next, I'm going to store the address part here. the head variable. Next, I'm going to delete the temp, which we have the data part. So of all the elements. So I'm closing my class here. Next, I'm defining my main function. I'm going to create a object for my linked list class named list. Next, I am declaring some variables named num insert and num search to perform insertion on the searching operations. These num insert will store the element which is inserted into the list, and num search will store the element which has to be searched in the list. So element will have the element which needed to be searched or inserted. Next, I'm going to prompt ask for the user to enter the number of elements which are needed in the list. I'm using cout function to ask the user to enter of the number of elements which have to be inserted. These elements are stored in num insert variable. Next, I'm going to ask the user for elements to be inserted. Next, I'm using a for loop to read and append the elements. Initially, looping variable index will be equal to 0. And if the index, the loop variable reaches num insert, then it has to stop looping. Next, I'm going to take input for my element. Here. Now I'm going to add the element to my list by using list.append method, which adds the element into my list. Next, I'm going to perform the search operation. Firstly, I will ask the user to enter the elements which are to be searched. So I'm using the statement which I have used before to fasten up the process. So I'm asking the user enter the element to be number of elements to be to search. Next, these number of elements are stored in num insert variable. Next, I will ask for the user the element which is needed to be searched. Next, I am using a for loop to to read and search for the elements. This for loop is used for reading through the loop and searching for if the element is present in the loop or not. So it has the same condition except if the looping variable index or looping variable reaches num insert num search, it has to stop the searching operation. Next, it's going to ask for to input the element. Next, I'm going to print the search result. For the element, if the element is present, it will print found. Otherwise, it will print not found. So I'm going to use search method on my list, which takes the element which is needed to be searched and checks if the element is present in the list or not, and displays if it is found, displays a found, otherwise it will display not found. So this is how I created a mass searching operation. How I have inserted elements into my linked list and how I have searched for the elements by using the above course. I'm using a return 0, which indicates successful completion of my code. So after running, it's showing enter the number of elements to be inserted. I want to insert 4 elements. Next, I'm giving the element to be inserted, which is 1. So first the list is empty. After insertion of 1, the last element after inserting will be 1. Next I'm inserting 2. Last element will be insert after inserting will be 2. Next I'm inserting 3. Last element after inserting will be 3. Last element, next I have inserted 4. Last element after insertion will be 4. Next it's asking, since I have number of elements to be, which I have given, have been successfully inserted, it's asking for number of elements to search. I'm giving number of elements to be searched as 2. Next it's asking enter the elements which needed to be searched. So I'm giving 1. So since 1 is present in my list, it's showing found, search found. Next I'm entering 20. Since 20 is not present in my list, it's showing that the search element is not present in my list. While coming to the time complexity for searching here, the time complexity for searching elements in the linked list is of big O of n.